Now, sometime you're going to be given a differential equation that you're going to be asked to find the constant. So they want a specific solution. So let's go ahead and knock ourselves out by doing this. So this one wants x dy by dx minus ln x equals 0, where y of 1 equals 0. This means when x is 1, y is 0. So let's go ahead and do this. So remember, we're trying to get x's on one side and y's on the other side. So first thing I'll do is bring over ln x. So we're going to have x dy by dx. And when you bring over ln x, so that is now going to be equal to ln x. Yeah, man, this equal ln x. Then look what I'm going to do. I'm going to multiply both sides by dx. Because if I multiply both sides by dx, I'm going to multiply both sides by dx over x. Instead of just multiply by dx, I'm going to multiply by dx over x. And you might say, that's crazy. No, that is not crazy. To multiply by dx over x, that will, look what it do to the left-hand side. This x cancels this x. This dx cancels this dx. And so what we end up getting is dy, we end up get 1 dy is equal to, this is now ln x over x. Yeah, man, this is now ln x over x dx. Yep, that's what we end up getting. So now, of course, we know the usual. We integrate both sides. So we're going to integrate both sides. Now, the integral of 1 dy, when you integrate 1 dy, you get y. And then that's equal to the integral of ln x over x. Now, I don't remember how we integrate ln x over x, but I know if we were to use u substitution, because we're going to get y is the integral of ln x over x. If you were to call u ln x, right? If you were to call u ln x, so run into a little danger here. So let's go ahead and call u ln x. If we call u ln x, we know that du would be equal to 1 over x dx. Yeah, man, so let's do that substitution. So now what we're going to get is y is equal to the integral of u is what? Ln x. So y is equal to the integral of u, then 1 over x dx is du. So that's what we get now. So what does that do for us? What that do for us then is y is going to be equal to integrate u du, we add 1 to the power. So we get u squared over 2 plus some constant k. But the question never given nothing with u. So what we have to do is go back and write our x. What was x? What was u? My bad. U was ln x. So to finish it off, you have to tell them that y is equal to ln x all square over 2 plus k. Y is equal to ln x square over 2 plus k. Don't like how that's so close. Plus k. But remember, we really can't finish yet because remember that we needed this. We need to find k. And they tell us y of 1 equals 0. What does that mean? That means that when x is 1, y is 0. So let's go ahead and do that. All right, let's do it on the whiteboard right here. So we've just found that y is equal to y is equal to ln x all square over 2 plus k. This is what we just found out. And they tell us that they tell us that y of 1 equals 0. So that means a point on the curve is when x is 1, y is 0. So plug that in. 0 is equal to ln 1, but ln 1 is what? ln 1 is 0. So that's 0 over 2 plus k, and so that means that k equals 0. So if k equals 0, then that means the final solution, the final solution, so that means the specific solution, I like to call it SP. SP means specific solution. The specific solution of the curve is denoted by y is equal to ln x squared. Y is equal to ln x squared over 2. That's what we have. Easy. So y is equal to ln x squared over 2. Nice. Alright, this example we have 1 plus x squared times dy by dx minus 1 plus y squared equals 0. So of course we know the drill already. So we're gonna do a little bit for, we're gonna move a little bit smoother here. So first we're gonna bring over 1 plus y squared to that side. So bring over the 1 plus y squared, that's the first part. All right, the next thing is that we notice we'll have 1 plus x squared dy by dx. So what are we going to do? The next thing that we're going to do, since we have 1 plus x squared dy by dx, by the way, put a bracket around them so you know that you're looking at it as one thing. You're going to cross multiply dx. By cross multiplying dx, you're going to get 1 plus x squared. You're going to get 1 plus x squared times dy. 1 plus x squared times dy is equal to 1 plus y squared times dx. This is what we're going to have. 1 plus y squared times dx. Then remember, our ultimate goal is to get the x them on one side and the y them on one side. So divide out 1 plus x squared and divide 1 plus y squared. That will end up giving us 1 over 1 plus y squared dy. This is what we're ending up getting, 1 over 1 plus y squared dy. I will end up get that this is equal to 1 over 1 plus x squared dx. This is what we are going to end up getting, that this is equal to. So if this is the case now, we can then integrate both sides. Integrating both sides, and integrate 1 over 1 plus y squared, what you end up get is tan inverse. This works out to be tan inverse of y. So tan inverse of y works out to be tan inverse of x. Tan inverse of x. Now since we get in tan inverse of x, and then we know plus our constant k, generally what they ask you to do is to write the solution in terms of y. So look what I'm going to do. What I'm going to do is, since I know that when x is 0, y is root 3, what I'm going to do is take the tan of both sides. So that means, this implies if you take the tan of both sides, then y is going to be equal to the tan, take the tan of both sides. Tan of tan inverse give y, and so y is actually equal to the tan of tan inverse. Y is now tan of tan inverse of x plus k. That is y, which all I did was take the tan of both sides to get rid of tan inverse. But always remember, tan of tan inverse cancel each other. Tan cancel tan inverse cancel tan. Then now we know that when x is 0, y is root 3. So when x is 0, when x equals 0, we know y equal root 3. So let's utilize that. Let's utilize that fact. Let's utilize that fact now. So when x is 0, put 0 here. What is tan inverse of 0? The tan inverse of 0 is 0. So since we know when x is 0, y is root 3, then that means that root 3 is equal to tan inverse of 0 is 0. So we end up with y is equal to the tan of, in bracket, tan inverse of x, which is 0, plus k. So this is what we'll get, 0 plus k. And so k is equal to tan inverse root 3. That is the constant. K is equal to tan inverse root 3. K is tan inverse of root 3. That will be k from right here. K is tan inverse root 3. But tan inverse root 3 is tan inverse of root 3. That is pi by 3. That is pi over 3. Now we get our answer. That's pi by 3. So now we can write the general solution. Now we need a little bit more space to write the general solution. So where can we fit it? Let's try and fit the solution just above here. So we're going to bring it up here. We're going to write the solution up here. And so the specific solution is going to be y is equal to the tan. Y is equal to the tan, because remember it's from here now. Y is equal to the tan of tan inverse. Y is equal to the tan of tan inverse of x plus k, where k is what? K is pi by 3. This is plus pi by 3. Easy, soft, pi by 3. Nice. That is that. Nice. Soft.